X is a normal variable with a mean 10 and standard deviation 2.5. Calculate the probability that x is less than or equal to 14, the probability that x is greater or equal to 16, and the probability that x lies between 8 and 13. So we're going to use our standard units formula to help us with this. And our standard units formula states that Z1 is equal to x1 minus the mean divided by the standard deviation. So for the distribution of x, the mean is 10 and the standard deviation is 2.5. So we're going to start off with working out the probability that x is less than or equal to 14. So we need to start by converting x1 equals 14 into standard units. So if x1 equals 14, then z1 is going to be 14 minus 10 divided by 2.5, which gives us 1.6. So we got this from our formula. So what we're going to do is draw out our curve, and if this is 1 and this is 2, then this is approximately 1.6. So we're interested where z is less than or equal to 1.6, so we're interested in the area to the left of that. So going to our tables, the probability that z is less than or equal to 1.6 is 0.9452. And this is the same thing as the probability that x is less than or equal to 14. So this is where we got it from our tables, 1.6 and 0.00. We get 0.9452. Part 2, the probability that x is greater or equal to 16. So again, we're going to use our standard units formula. So for the distribution of x, the mean is 10 and the standard deviation is 2.5. So if x1 is equal to 16, we get z1 equals 16 minus the mean, which is 10, divided by the standard deviation, which is 2.5, which gives us 2.4. So we draw out our curve, and if this is 2 and this is 3, then this is approximately 2.4. So if we're looking for the probability that x is greater or equal to 16, that's the same thing as the probability that z is greater or equal to 2.4. So what we're going to do, instead of getting the probability that z is greater or equal to 2.4, which we can't do, we're going to get the probability that z is less than 2.4 and subtract it from 1, because the entire curve, the area under the entire curve should add up to 1. So we get 1 minus the probability that z is less than or equal to 2.4, which gives us 1 minus 0.9918, which we get from our tables, which is equal to 0.0082. So the probability that z is less than or equal to 2.4, we go to 2.4 and 0, and we get 0.9918. And subtracting from 1, we get 0.0082. Part 3, the probability that z lies between 8 and 13. So again, we'll use our standard units formula. So for the distribution of x, the mean is 10 and the standard deviation is 2.5. So for x1 equal to 8, we have z equals 8 minus the mean, which is 10, divided by the standard deviation, which is 2.5, which gives us minus 0.8. And for x2 equal to 13, we get z2 equal to 13 minus the mean, which is 10, divided by the standard deviation, which is 2.5, which gives us 1.2. Thus, the probability that x lies between 8 and 13 is the same thing as the probability that z lies between minus 0.8 and positive 1.2. So this is the same thing as the probability that z is less than or equal to 1.2 minus the probability that z is less than or equal to minus 0.8. So if we work out this probability, that's the probability from 1.2 all the way over to the left tail. And if we work out this probability, which is the probability from minus 0.8 all the way over to the left tail, if we subtract this, then we're left with what's in between the two. So the probability that z is less than or equal to minus 0.8 can be rewritten as the probability that z is greater or equal to positive 0.8. Because remember, we cannot deal with minuses in our table. So this is equal to this because our curve is symmetric. So a quick way to do it is, if you want to change the sign, you're just flipping the inequality. So the probability that z is greater or equal to 0.8, so again, we cannot work this out because we can only work with less than. But if we get the probability that z is less than 0.8, and we take it away from 1, then we're left with the probability that z is greater or equal to 0.8. So we have the probability that z is less than or equal to 1.2 minus 1 minus the probability that z is less than or equal to 0.8. Now minus times 1 is minus 1, and minus times a minus is plus the probability that z is less than or equal to 0.8. Now we can work out each of these. So the probability that z is less than or equal to 1.2 is 0.8849, and the probability that z is less than or equal to 0.8 is 0.7881, and then we have to subtract the 1, which we got from here, and we're left with 0.673. So we can see it a bit more clearly here. So the probability that x lies between 8 and 13 is the same thing as the probability that z lies between minus 0.8 and 1.2. So here's minus 0.8 and here's 1.2, so we're looking for the area in between. So we end up getting the probability that z is less than or equal to 1.2 as 0.8849. So get that from here. And the probability that z is less than or equal to 0.8 as 0.7881. So we get that from here. And then subtracting the 1, we have 0.673.